chapter 3.4, we just got through talking about in chapter 3, angle pairs that are generated when you have lines being intersected by transversals. Okay? We've got alternate interior angles, alternate exteriors. Well, all the angle pairs we've talked about. You can listen to the video from yesterday to get that information. A special situation takes place, however, when transversals cut across parallel lines. Okay? Now, we've got line T right here. Okay? Cutting across two parallel lines. Now, the way we indicate lines are parallel pictorially is the lines here. You're going to see a couple of arrows drawn across those lines, which indicates that they're parallel. Okay? So lines J and K are parallel. Line T is a transversal. I've got 8 angles pictured here, 1 through 8. Now, when this is the situation, there's the first thing we need to contend with is postulate number 8 on page 128. What does postulate 8 read? Postulate 8. What does it tell us? It tells us that corresponding angles are congruent. Now, what is the difference between a postulate and a theorem? Yeah, postulates are accepted. No, the way it works is this: postulates are accepted as true without proof. Okay? Yeah, theorems, you have a rational set of statements and reasons to establish the truth of a statement that we call a theorem. A postulate is a statement accepted as true without proof. So corresponding angles are congruent. All right? So this is what we know from postulate 8. We know that corresponding angles are congruent. Get used to geometry shorthand, okay? Now, so what do we know then about angles 1 and 5? Their corresponding angles. What can we say about them?
They are congruent.
So they're congruent, right? What about 2 and 6?
Yeah.
Same thing, right? So all the set of corresponding angle pairs we can identify here are congruent. Now, on page 129, theorem 3.5. All right, theorem 3.5 tells us that alternate interior angles are congruent. Okay? Alternate. So this is theorem 3.5, right? Alternate interior angles are congruent. Now, this is something we have to establish the truth value of. Normally, I would establish a formal, and in most textbooks, they would establish a formal 2-column proof. Let's just reason through this to establish alternate interior. What's an example of alternate interiors in here?
Alternate interior?
Yeah.
4 and 5.
4 and 5. So let's talk about this. Let's go to 3 and 6, since that's actually what I've got up here. 3 and 6 are alternate interiors. We're going to establish the fact that they are congruent. Now, how do we do this? Let's first of all begin with angles 3 and 7. What type of angle pairs are 3 and 7?
Angle pairs of
3 and 7. Work with me on this. No, 3 and 7. They're corresponding. What do we know about corresponding angles? The postulate 8 tells us they're congruent, right? Now, what do we know about angles 6 and 7 with respect to each other? Yes, they're vertical, right? So we have a theorem from chapter 2. We have a theorem from chapter 2 that says vertical angles are congruent. So I can now say 6 and 7 are congruent. Now, what property of congruence or equality can allow me, therefore, to go from saying 3 congruent to 7, 7 congruent to 6? Why can I now state that 3 is congruent to 6? Okay, so we've got the situation established now where we can say angles 3 and 6 are congruent. Now, what property of equality or congruence allows us to make that statement? This one right here. We know that 3 is congruent to 7 because these are corresponding angles, right? 6 and 7 are congruent because they're vertical. What property says that I can now state formally that 3 is congruent to 6? And what do we call that? I know you're thinking right. The transitive property, remember that? It's your transitive property that allows us to make that connection. So once you've established the truth claim once, you can use it as often as you want without having to go back and reestablish it through this chain of reasoning. So in other words, what I'm saying, if I can say 3 is congruent to 6, I can, using this thought process, I can automatically therefore jump and say now 4 is congruent to 5. Okay, I don't have to reprove it. I could. I mean, I could say 8 is congruent to 4, 8 and 5 are vertical, 4 and 5 are congruent. Same, I don't need to though. Once you've established the theorem once, you can use it all you want to. So, both of these are true statements now. All right? Now, alternate exterior angles are congruent. You can use the same rationale here. All right? Using that same diagram, what is a pair of alternate exterior angles? 2 and 7? Right?
1 and 8.
So can I state that 2 and 7 formally are congruent? Well, yes, I can. And why can I say that? Well, 2 is congruent to 6, 1. Why is 2 congruent to 6?
1 is congruent to 5.
Oh, because they're corresponding.
They're corresponding. That's what I'm looking for. So 2 is congruent to 6 because they're corresponding. 6 is congruent to 7 because they're what? They're what? What kind of an angle pair are 6 and 7?
Oh,
Yeah, they're vertical. And so now the transitive property allows me to say 2 is congruent to 7. The same thought process, okay? Now, that basically takes care of what we need to have discussed here with chapter 3.4, the relationships between the angles, the corresponding angles, alternate interior angles, alternate exterior angles. Now, there is one other theorem in here, theorem 3.7, that we need to discuss. Okay? This is going to be your homework assignment right here. So let's talk about this first, okay? Apparently I forgot to do this last period. So, theorem 3.7. All right, and that says this. Same side interior angles. Same side interior angles are supplementary. What does supplementary mean? 180. In other words, they equal 180 degrees. Okay? Now, how can we establish same side interior angles? Let's look at our diagram here. Give me a pair of same side interior angles. 3 and what?
5.
3 and 5, okay?
I'm doing the whole.
Now, the thought process works like this. We know that, regarding this, we know that angle 1, the measure of angle 1, let me jump down here. We know that the measure of angle 1 plus the measure of angle 3 is going to equal to what? What is measure of angle 1 plus 3 going to equal to? 180, right? Why? Because they're a linear pair, right? Okay. So we know they equal to 180 degrees. All right? Now, we also know this. Angle 1 is congruent to angle 5, is it not? Why? Why? Yes, because they're corresponding. So I know that they're congruent. I know that their measures are the same. Measure of angle 1, therefore, is going to be equal to the measure of angle 5, right? So now I can say this. I can make a substitution and say that since I can now say that measure of angle 3 plus the measure of angle 5 is equal to what? 180. What is my justification for stating that if I were to make a formal two-column proof here? This statement was because these are a linear pair. This was made because corresponding angles are congruent. Okay? So what did I do here to say 3 and 5? Instead of 1 and 3, I made a substitution, right? Substitution, property of equality. So, same side interior angles are equal to 180 degrees. You can make the same argument, by the way, with same side exterior angles. We could go through the same process. So that angle 1 and angle 7. I could I'm just going to cut to the chase here. I also can say that measure of angle 1 plus the measure of angle 7 will equal to 180 degrees, okay? It's not a very good 180. My smart board's kind of a stupid board right now. Okay. That is pretty much that covers the information that you need to know to do this section, okay? I think I'm going to stop it right there.